We are going to start with a few more planning questions here. The question is from May June 21 and the variant is photo. I'm just reading out the question and then side by side I'll be solving, helping you to solve it as well. So the question says that ammonium sulfide is a water soluble compound. You have a sulfite here, right? Now, number one, they're saying it's a water soluble. Then further, the next statement is aqueous ammonium sulfide is slowly oxidized by oxygen in air. So we know that the sulfite will be oxidized by the oxygen and it will be converting the sulfite into sulfate. So this is an oxidation process, right? So that means whatever the sulfite ions we have, because they're getting oxidized, we can make it react with an oxidizing agent and see whether it's being oxidized or not. And the lab oxidizing agent, we know we have acidified potassium permanganate and we have acidified potassium dichromate. So both these oxidizing agent will change color on oxidation of any compound. So KMnO4 will change from purple to colorless, whereas potassium dichromate will change from orange to green. So this is a common understanding we have. Moving ahead, so sulfite is actually oxidized by oxygen and hence the sulfate will also be present even though we are taking the sulfite solution. This means aqueous ammonium sulfide will also contain some of the sulfate that they have given in the statement form. Now what you have to do is, this is a task. Describe a series of tests and the observations. You have to give the test and the observation to show the presence of ammonium ions, sulfite ions and sulfate ions in the solution. It must be clear in your answer which ion is identified by which test. Okay, so we have to identify the ammonium ions, right? Ammonium ions we have to identify, and we give the test for sulfate ions and we have to give the test for sulfite ions. Out of these, we have two anions and we have just one cation, right? So these tests we have to specify the tests along with our observations, and definitely on the basis of observation, our inference will be based. Now, for example, let's take the anions first. So in the series, let me talk about the first test. What I'll do is with the sample. In the sample, I will add my oxidizing agent, any oxidizing agent. Let me name it. If I add acidified potassium permanganate, okay. So I'll be adding an oxidizing agent, or I can say I can add KMnO4 in the acidified form. If the observations are that the purple color disappears to give colorless solution, to give colorless solution, then what I can inference, what I can conclude from this, that the oxidizing agent is able to oxidize the substance which I've taken as a sample. Okay. So which out of these three, which has the capability of oxidizing, this oxidation number increase or subtract? We know that the sulfide can get oxidized into the sulfate. So the inference will be that the solution or the sample contains my sulfite ions. Okay, so on the basis of this observation, because the color of KMnO4 is changing, so I know I have a sulfite ions. Now next to another sample, now I have to test for, let's say, sulfate. Now in the sample I will add dilute nitric acid in order to remove any traces of any other ions which can give me the precipitate formation. So I'm making all the such ions convert into nitric acid, and then to this I will be adding my barium nitrate solution. Okay, aqueous barium nitrate. On adding these two chemicals, on adding barium nitrate aqueous solution, if I'm able to see the white PPT there, once able to see the white PPT there, then the conclusion will be, the inference will be that this particular sample or solution contains the sulfate ions, because I'm getting the white PPT of barium sulfate, and that's a positive test for the sulfate ions. Okay. Now coming to the cation. The cation is basically ammonium, and for the cation, for the ammonium cation specifically, we tested with aqueous ammonia. we tested with sodium hydroxide. Now the test is that to the sample, if we add aqueous sodium hydroxide and warm it, on warming we will be seeing a pungent smelling gas, okay, liberated, and a gas which liberates, the gas which liberates, if turns moist red litmus red litmus paper to blue. That's proving that the gas which is being liberated is basically alkaline nature. And in our syllabus, we have only one alkaline gas present, that's ammonia. So from this particular conclusion, this observation with it, because it's converting the red litmus paper into blue, we are sure that we have ammonium ion present in the sample. So this is how, these are the three tests, and these are the three observations, and these are the three inferences of the conclusion which I have drawn on the basis of the observation. So this is how you'll be able to score the maximum marks at 6 marks. Okay, this is another question on planning, and it's from October, November 20, variant 4.1. And so question number 4 in the ATP paper, the given ATP paper, right? So I'm just reading out the question to you people, and then we'll work it out how to solve, how to plan the experiment to prove whatever is the demand of the question. A student wants to electroplate a metallic spoon. Electroplating, we know electroplating is a process where an active anode is involved. It's an application of electrolysis. So what they need to electroplate a metallic spoon with a layer of copper. It needs to be electroplated with copper. Now you have to plan how the student does the experiment. So the electroplating has to be done and the planning has to be done for that. That's the demand of the question. Now, while planning, you have to remember the following points: the state what needs to be done to the spoon before the electrolysis, before even the process started, what you're supposed to do, right? Number two, include a label diagram of the patterns. Definitely a label diagram is better than 1,000 words. So if you make a label diagram, the process itself will be very clear and your concept will be judged properly. Now, number 3 pointers, give the names of the substance used. So whatever the substance or chemicals you'll be using, you have to give their names as well, okay? So let's move on how to plan this particular question. So this is the diagram. This is a diagram for the electroplating of copper on the spoon. So because the substance to be electroplated, we always keep it on the cathode, right? So the spoon need to be electroplated, so we kept it on the cathode. And the substance with which it need to be plated should be kept on the anode. This process is of active electrode process. ठीक है, जहाँ पर हमारे पास electrode जो होता है वो दो तरह के इलेक्ट्रोड होते हैं, एक इनर्ट होते हैं और एक एक्टिव होते हैं. Inert electrodes do not interfere with the process of electrolysis, but this is an active, so its interference is there. But active electrode भी कौन सा है? Inert. How we identify whether it's active or inert electrode? So we identify if the anode is dipped in its own salt solution. So we have a node of copper and it is dipped in its own salt solution, copper sulfate solution, then that is going to act as an active electrode. एक्टिव इलेक्ट्रोड की दो एप्लीकेशंस होती हैं, आपकी इलेक्ट्रोप्लेटिंग होती है और इलेक्ट्रो रिफाइनिंग होती है. अब नाउ दिस इज बेसिकली the concept of active electrode or active anode will be applied here. Now they ask us to draw the diagram for the process of electrolysis. अब मैंने जैसे आपको बताया कि active electrode में copper, we have to plate the spoon with the copper has to be at the anode. The substance with which it need to be plated should be on the anode. And anode is what? Anode basically at the anode, the anions will be traveling. So anode is an electrode which is basically positively charged, and the cathode is the terminal or the electrode which is basically connected with the negative terminal of the battery, right? Now what happens here when the electrolysis start, right? होता ये है कि आपका जो एनोड है जो कॉपर का बना हुआ है ये अपने आप को ionize करना शुरू कर देगा और copper as a solid substance is going to ionize and it's going to turn into copper ions. ठीक है, अब ये copper ions जो है ये jump होकर solution में आएंगे और जो plate पे हैं वो electrons रह जाएंगे because the copper metal is losing electrons and those electrons are left on the plate. ये electrons through an external circuit will be traveling towards the cathode. solution में copper ions jump करके आ गए because electrons were left on the plate. Now what will happen next is that these copper ions, the anode कैथोड पे हमेशा हमारा जो है वो रिडक्शन होता है. दैट मीन्स कैथोड पे आपका जो है वो कॉपर आयंस आएंगे और वो इलेक्ट्रॉन्स को गेन करेंगे. ठीक है, कॉपर आयंस दे विल बी ट्रैवलिंग व्हाटएवर द कॉपर आयंस आर देयर इन दिस इलेक्ट्रोलाइट, चाहे वो इलेक्ट्रोड एनोड से आ रहे हो चाहे वो अपने ही सॉल्ट सॉल्यूशन में हो, तो वो आयंस जाएंगे टुवर्ड्स द कैथोड एंड दे विल एक्वायर इलेक्ट्रॉन. On acquiring the electron, they will be forming copper, and this solid copper will be depositing itself on the surface of this metal spoon. Now, because of this deposition of the copper on the surface of the spoon, that is actually the process of electroplating. Okay, this is the process of electroplating. So this you will be explaining. This is a well-labeled diagram which is going to explain, right? And what else they want, let's start we will be starting our explanation because the examiner wants us that before this electrolysis take place, before the process take place, what are we supposed to do with the spoon? So the spoon has got a shiny and surface on which it's on the ions might not stick on. ठीक है, जो आपके जो deposition हो रहे हैं metal के वो stick on है. So we will be preparing the spoon by cleaning its surface, so that आपके जो भी ions हैं उस पे deposit हो जाए. By using clean its surface by using sandpaper, आप उसको sandpaper से rub करेंगे. ठीक है, ताकि आपके ऊपर से surface clean हो जाए और आपके जो भी electrolysis के दौरान जो भी ions हैं, जो भी metal है, copper metal है, वो उसके around deposit हो जाए. So this is what they are demanding. Then you have to include a label diagram for the apparatus. So I'm showing the label diagram. This is my anode and this is basically my active anode because it's dipped in its own solid solution. So anode से cathode की तरफ आपको हमेशा electron transfer होता है. That I'll be showing the electron transfer. Similarly, anode से आपके copper ions आ रहे हैं jump करके और electrons आपके plate पे हैं और वही anions either the same anions which are jumping into solution or the copper sulfate के जो copper ions हैं, they will be accepting electron to deposit as a copper. तो होता यहाँ पर ये है कि copper sulfate की concentration unchanged रहती है. ठीक है, जिसकी वजह से एक observation आपको नजर आती है. The observation is that the blue color of the solution remain intact. The blue solution remain same. ठीक है, उसकी कोई concentration कम नहीं हो रही क्योंकि copper ions ही that remains the same. सही. So give the name of the substances used. The name of the substances used or the reactants used will be that means they're demanding the name of the electrolyte. So we will be using aqueous copper sulfate solution as an electrolyte. So supporting this particular diagram, the process, you have labeled the diagram, you have written the cathodic, anodic equation, what's actually happening, and what is making the electron, what's making the copper stick on to the cathode, and then this is going to be the overall equation. So anode पे आपके पास copper होते हैं, वो lose करते हैं electron, they'll be losing electron to form copper ions. These copper ions will be accepting electrons to form copper, and this is how आपके कैथोड के ऊपर डिपोजिशन हो जाता है, and this is actually leading to electroplating.